Hello, Math Humans. We're going to do 7.2 today. We're going to be solving systems of equations by elimination. Our objectives are to solve systems of equations by elimination. So if you will remember from previous math classes, elimination is manipulating equations to eliminate a variable and then use substitution. So let's just start by doing some examples. So I want to solve by elimination. My first system is going to be 3x plus 5y is equal to 7. That's a 7. And a negative 3x minus 2y is equal to a negative 1. So when I'm solving for elimination, the goal is to make one of the variables go away by making one term be positive, one term be negative, the exact same value. And then when I add the two equations together, one of those variables disappears, and then I can do substitution. So 3x minus 3x is 0, 5y minus 2y is 3y, 7 minus 1 is 6, y is equal to 2. So that was really simple. Then I take this value and I substitute it back into either one of those equations, whichever one is easier. I'm going to choose the second equation just because. So I have a negative 3x minus 2 times the value that I found for y is equal to a negative 1. And I get a negative 3x minus 4 is a negative 1. A negative 3x 4 minus 1 is 3, and then I get x is a negative 1. So then remember, when we report in ordered pairs because it is a point between two lines. So there is my solution. That was pretty easy. Nice, polite way to start the day. The second example again says solve by elimination. This system is going to be 2x minus 4y is equal to a negative 7, and 5x plus y is equal to a negative 1. Now, in this particular system, I would probably choose to eliminate the y's because I have less math to do. So I'm going to multiply both sides of the equation by 4. So my first one stays the same. I didn't do anything to it. The second one is going to become 20x plus 4y is equal to a negative 4. Then I'm going to add those two equations together. 20 plus 2 is 22x. A negative 4 and a positive 4 is 0 is equal to a negative 11. X is a negative 11 over 22, which is a negative 1/2. Okay, so x is a negative 1/2. And then I'm going to substitute that back into one of these equations to solve for y. I'm going to substitute it in here because 2 times a negative 1/2 is going to be easy math. So 2 times a negative 1/2, the value that I found for x, minus 4y is equal to a negative 7. 2 times this, the 2's cancel, and it leaves a negative 1. So I'm getting a negative 4y, a negative 7 plus 1 is a negative 6, and then y is equal to 6/4, which is 3/2. So then if I report, my solution is a negative 1/2, 3/2, all done. And there's no reason to convert that particular problem to decimals. Fractions are our friends. All right. The next thing that we want to talk about is the number of solutions for a linear system. So it's kind of cool to think about. I could have exactly one. So there is one and only one solution. And that would be the case like we've been doing if I have two lines that intersect in one spot, there is only one solution. The next solution is kind of interesting to think about. I could have infinitely infinitely many solutions. So let's say here's my handy dandy little graph, and then here's the first line. Well, and as it just so happens, the second line is right on top. So those two are the same line. So that means that every point along that line will be a solution to the problem. The third possibility is no solution. And if you think about that, if we're talking about lines, so if this is my first line, and no solution means the two lines never intersect, so that means that I would have parallel lines, and parallel lines never intersect, therefore no solutions. All right, so now we're going to do our next example. This is going to be example number 3, and it says solve the system analytically, which means, yeah, math, it means we're going to do some algebra. So for the system is x minus 2y is equal to 3, and a negative 2x plus 4y is equal to 1. I might choose to eliminate x in this particular system. So I'm going to multiply the first equation by 2, and I get 2x minus 4y is equal to 6. The second equation doesn't change, plus 4y is equal to 1. You should already see a little bit of a problem. When I add those two equations together, I get 0 equals 7. This is an untrue statement, so therefore there are no solutions. And then if you actually graph these two lines, so you would have to put them in slope-intercept form, you would see that they are indeed parallel lines, so there's no solution. All right, example number 4 says the same thing, solve the system analytically. Sometimes I struggle to spell that word. So this system is going to be 2x minus y is equal to 1, and 4x minus 2y is equal to 2. And on this one, again, I'm going to do elimination, and I'm going to eliminate the x just because. So I'm going to multiply the first equation by a negative 2, because for elimination to work, one of the signs needs to be the opposite sign. So then I'm going to have a negative 4x plus 2y is a negative 2, and 4x minus 2y is equal to 2. Well, that's weird. You should already notice that that looks kind of unusual. When I do this one, this left-hand side is 0, but so is the right-hand side. That's a true statement. That means that there are infinitely many solutions, because no matter what value you choose, what ordered pair, it's always going to be a true statement. Alrighty, I have one more example for us. So we're going to do our last example. So it's going to be example 5. And this says, solve the system, and your favorite A word, analytically. My favorite A word, other than maybe A for apple and apple pie. All right, this is an interesting system, and I'll tell you why I chose this system in just a moment. So a negative 0.38, and the other one is 0.03x plus 0.04y is equal to 1.04. So when you look at this, you might think, oh no, I have decimals. But actually, we don't need the decimals. So I'm going to kill the denominator, because remember, 0.02 technically is 2 divided by 100. So since these numbers are in the hundredths place, I'm going to multiply this equation by 100. This is the exact same situation, so I'm also going to multiply this equation by 100. So the first equation becomes 2x minus 5y is 38. The bottom equation becomes 3x plus 4y is equal to 104. Now that system looks much easier. So I'm going to do elimination on this one. And when I solve, I'm going to eliminate the x's just because. So I'm going to multiply this equation by a -3, and then I'm going to multiply this equation by 2. So my system is going to become a -6x plus 15y is equal to 114. And then I'm going to get 6x plus 8y is equal to 208. Now I'm going to add those two systems together, and I'm going to get 23y is equal to 322. And when I do that math, I'll come up here because we're almost out of space. I get y is equal to 14. And then I'm going to substitute this y value back into one of these two equations. It doesn't matter which. And I'm actually going to skip that step right now because I think that you can do that in your math brilliance. And so there are my numbers. And so when I report, I would say that the solution is 1614. So anytime that you have problem equations, if it's decimals, multiply by the decimal place. If it's fractions, multiply the whole equation by the lowest common denominator. We call that kill the denominator, and it will make the math significantly easier. All right, my dears, that is it for today. I will see you soon.